we're starting chapter 3. This chapter is actually going to go a lot more quickly than the other ones. Why? Because we've already covered most of the material. You know the way that I front load stuff before we actually hit it. So this chapter, in a way, a lot of it's review. You know, that doesn't mean that we're not going to do it justice. It just means that it's not going to take a month to get through it like it did chapter 1 and then another month for chapter 2. You could get through it in 2 days. We'll see about that, but let's take a look. Understanding structure. The disadvantages of unstructured spaghetti code. Well, what is spaghetti code? And they don't give any examples. One reason they don't give any examples is it's a lot harder to write spaghetti code anymore than it used to be in the past. What is spaghetti code? Well, back in the old days, and some languages still even support it, you had what are known as jump or go-to statements. You don't have to take these notes. Absolutely do not have to take them if you don't want it, because I'm going to write a little program that in another language that's not a real language, and etc. So say you had this code. Print, enter a number. 20. Input X. 30. If X greater than 5, 6, go to 80. 40. Y equals Y plus, let's just make it simple. Print X. 50. There's no indentation in this language. Go to 10. 80. Print. Done counting. And then 90, go to 200, 100, print, okay, and then 200, go to 100. All right, so what is this doing? First thing, print, enter number. Great. Input X, okay, so we typed in 1. Is X greater than 6? No, it's not. All right, I left off an important statement, so I'm going to modify it. I'm going to come back in between here and here, I'm going to add a statement. X equals X plus 1. All right, so we program by these line numbers, which is great until you need to insert a whole bunch of code at this particular point, right? You know, you saw me, I was able to squeeze in 1, but you can't type in 41.1 and 41.2. Okay, so anyways, we typed in 1. X was not greater than 6. So we printed out X. We print 1. We add 1 to X. Go to. Jumps back up here. Enter number. 2. I'm actually going to change my program because I did not want it to go back to entering a number. I just wanted it to go back to that. All right. You're kind of already seeing that. This is kind of confusing. All right, so we added 1 to X. X is now 2. Now go to 30. 30 is X greater than 6? No, it's 2. Print it out. Print 2. Add 1 to it. It's now 3. Go to 30. Jump back up. Is 3 greater than 6? Nope. Print it out. Add 1 to it. Go back. 4 greater than 6? Nope. Print it out. Add 1 to it. Go back. Is 5 greater than 6? Nope, but we're just about done with this. Print it out. Add 1 to it. Go back. Is 6 greater than 6? No. Nope. Now it's 7 greater than 6? It sure is. Jump to 80. Print done counting. And then go to 200. Go to 100. Print OK. Go to 100, and now it's in an infinite loop. So you get the idea. There's these jump statements. It's going all over the place. If we drew lines from where the jumps were going, you know, there'd be lines all over the place. That's why it's called spaghetti code, because, you know, if you were drawing lines from the go-to statements to their targets, it, you know, becomes all very confusing. What if you did something even more horrible like this? You know, line number 5, Z equals 80. And then, you know, if X is equal to 6, go to Z. And then later on, you change Z to another value, right? 985, you know, Z equals Z times 2. And then you tried to go to Z again. Right, anyways, you get the idea. It's really, really difficult to follow that kind of code. And that's pretty much what you had to do when you were doing assembly programming, except if you did assembly programming, you didn't write it in this nice mnemonics with English words. You used little abbreviations that corresponded with the opcodes of the processor you were using. Instead, I wrote it in something very close to the original version of the basic programming language. Then the basic programming language tried to add some additional structures, like a for loop. So you could say for x equals 1 to 5, or x equals 1 to 6. And then down here somewhere you'd have a next x, and it'll jump back up. And that cleans stuff up a little bit. But spaghetti code jumping all over the place, you can't do that in Python because we don't have a go-to statement. You don't have a jump-to statement. You don't have a jump statement. So, logically snarled, often a complicated mess. Programs often work, but you saw me, I had to keep fixing it in ways that I would not have had to fix if I'd had nice little while loops and stuff like that, or for loops and stuff. Difficult to read, difficult to maintain, confusing and prone to error. Unstructured programs do not follow the rules of structured logic. Well, guess what? A structured program then is one that follows the rules of structured logic. Fortunately, Python forces us to write structured programs. Now here's an example. Now you couldn't even implement this in Python. For one thing, this is a do loop, and we don't have do loops. And then in other cases, there's probably just, absolute go-to statements. Yeah, there's just go-to statements and stuff like that. So you could draw a flowchart that's not possible to implement. Catch the dog. Does the dog run away? Yes. Come back. Catch the dog. No. Turn on the water. Does he run away? Yeah. Turn off the water. Catch the dog. Does the dog have shampoo? Yeah. Well, then come down here and rinse the dog. No. Well, for some reason we apparently never... Okay, by the time we finally get to here, we apply the shampoo, we rinse the dog, and we stop. But it's a big old snarled mess. This could be structured with structured programming. This could be structured with a structured flowchart without lines going all over the place. So the structure, the basic unit of programming logic. Each structure is one of the following. And I would give one more. I say that there's 4 types of structures. They say there's 3. I would call a function call a structure, a module call its own structure. But they don't, so let's go with it. You can have a sequence, you can have a selection, which is an if statement, and you can have a loop. Pretty much any program can be constructed with these 3 structures. I still would put modules as a 4th structure. So sequence, performing actions or tasks in order. No branching, no go-to statements. No skipping any task if it's a sequence, right? So sequence is just when you have a bunch of statements tacked onto each other, one after the other. No changes in indentation level. Like this. This is a sequence of statements, right? Input y, print x plus y, print x minus y, print x to the power of y, input x, right? So that's a sequence. If you don't have any ifs and you don't have any loops, then all your program is a sequence of commands. That's okay if it does what you want. Most programs are going to have loops. Most programs are going to have branches in real world, unless you're just writing something to perform a little physics calculation because you're stuck on your homework and you don't feel like typing it into your calculator. Okay, great. Then there's the selection statement. Structure. You ask a question taking one of 2 actions based on testing a condition. Oh, and by the way, in this class and the other, I've seen some programs written like this. I'm not going to even fill it in. Flowcharts, I mean. You did not get full credit for this. All you have to do is fix it, get 100% credit. Come on, get back over there. And both of those were input statements. And if you're one of the folks who did it, no shame. You're certainly not the only one who did it, but it is not correct. And somebody tell me what is not correct about it. Pretend that these all just go back to that correctly. So that's a start up at the top. All right, somebody who didn't draw it like that, tell me why they didn't draw it like this.
If those are input boxes, then you can't give two different inputs at the same time.
Right, you can't get two different inputs at the same time. You don't know which way to go if you were trying to do one after the other. The correct way to do it is to make a sequence out of it. So, the only time you can have two lines leading away from a block is if it's a diamond. Like that. That's the only time you can have two lines leading away from a block. Not from the start, not from anything else, just from that. So to fix that, we just have to stack the blocks, make them a sequence, delete all these spurious lines and fix the way that those lines look. So if you got dinged off points for that, all you have to do is redraw so that the boxes are stacked on each other. Make all the changes necessary for that to work. Right. Like that. That's just about the most common error. But hopefully after you fix it once, you'll never make it again. Another mistake I've seen is making an if statement out of something else, like that. You didn't write the if, you didn't put an if block down there. Right, you didn't put an if under there. Instead, you just made the double branch. It's kind of the same thing here. But, you know, I could see where the logic was going. You know, this one would say, you know, print, it's frozen, as to this one would say not frozen or whatever. I could tell that that was not supposed to be an if statement. All you got to do there is tack the if statement on, draw the block, right, and then you're good to go. Two lines going away from this because it's a selection, it's a decision. Another thing I've seen is that, you know, and there was something over here, and, you know, no shame, guys. Y'all are learning it. It's okay. It's okay to make mistakes. That's why I give you 100% if you redraw it and turn it in again. On the exam, I'm going to want you to do, you know, a little bit better. I'm not going to give you a chance to redraw the flow chart on it unless you, like, totally failed it. I might take some pity and give you half credit if you redrew it later. I don't know. I just about never do that. So, because an exam's an exam, right? But anyways, this was supposed to print out freezing. This one was supposed to print out not freezing. What's the problem? There are dead ends. You can't have any dead ends in your program. They all have to end in an oval. Now conceivably, and don't do this, we're certainly not at the point where we do this, you could have some return statements like that. That would let you get out of the program in more than one ways. Having multiple return statements is absolutely something we're not doing. We haven't even hardly had any single return statements. And another is the break statement, which is kind of hard to flowchart at all. I'm probably not going to even try to flowchart something with a break statement, so I'm certainly not going to give you one. So just consider it a general rule that they always have to hook back up, right? Can't have a dead end. They always have to hook back up. And if you did that, you draw it like that, and you're good to go. And on some bodies, I kind of hand drew this structure, you know, on my tablet, and so if you can't make sense out of my drawing, hopefully you recognize this. If you can't make sense of my drawing, then text me a message saying, could you do this a little bit more clearly? You know, and I'll draw it on pen and paper and send a picture back to you. All right, back to where we were. That's a sequence. This is worth taking notes about. Why don't we do it in idle? spaghetti code. Uses jumps or go-tos. Python doesn't support that. Jumps all over the place. Make the code very difficult to read and maintain and make sure it works. Right. And so the Apollo moon landing folks, they wrote their code all in assembler because the computers, that drove the Apollo moon landing are probably far more primitive than the ones in your microwave. And so their code was not spaghetti code, so to speak, because they went to an awful lot of effort to try to emulate the structures. See if we can find an example of it somewhere. You see, and I'm actually surprised to see it like this. Often assembly programmers would document just about every single line of code. And they might even put indentions like this in order to indicate that a loop was beginning and ending, just like our language. They did not have loop structures. And so they broke things up into modules like this. They documented every single line. They went to all that trouble to try to emulate logical structures, because you can emulate logical structures. You did see that I had a loop set up here, right? It was hard to read, but that is a loop. And if we had, spaced it out like this, and put, count from X to 6, right? And then we put another comment out here, repeat loop. Now it's becoming more understandable. And if we didn't have, BS like doing that, and doing that and stuff like that, right, then, the code becomes more manageable, easier to read. But, so that was the challenge, was trying to write structured code with those languages. Just because you could didn't mean you had to. So we avoid spaghetti code one of two ways. One, we don't use jumps or go-tos. And just, as a caveat, if you had a language that all you had to is that you would have to simulate the logical structures that we're about to follow. And two, use logical structures. What are the logical structures? One, sequential. Just line after line of code, right? I mean, it could only be two statements, right? But it's still a sequence at the same indentation level. Statements are executed one after the other. Statements are done one after the other with no skipping, branching, or looping. So input, what is your name? Print hello name. Print done. There, our first program that we did on day one. Sequential code only. So two. Sneak a peek. Selection structure. That's your if statement. Some other languages have what's known as a switch statement. A switch statement is an if statement that can go in more than two ways. We don't have a select statement, so I'm not going to talk about it. The book probably does. So an if statement is a branch. Goes one of two ways. Depending on whether the condition is true or false. Now that I've, free-handed the definition of a selection structure, I'll go back to the PowerPoint and take a look what they say about it. All right, so they say, ask a question. I don't like that. Ask a question. If statements don't always, based on asking the user a question, but we take one of two actions based on testing a condition. That's the real statement. Take one of two actions based on testing a condition. I kind of worded it like that, but why don't we do that exactly? Take one of two actions based on testing a condition. The condition is either true or false, which is a Boolean expression. X equals 3. That resolves to true or false. Right? Y greater than 10. Input equals yes. Right? Except in all those cases we would use equal. So the condition is known as a Boolean expression. Boolean meaning true or false. Often called if then else. That's what it's saying. And when we say often called, that's what it's called in our language. As it is in Python. And just about every other language that I've ever seen. When I say just about, in absolutely 100% of the languages I've ever seen. Except we don't have a then keyword. And there are essentially two kinds of ifs. There are dual alternatives and single alternatives. Dual alternatives mean that based on the if statement it does one of two things. If hungry, eat. Else, say no thank you. Dual alternatives. If stop sign in front of us, apply brakes. Else, apply accelerator. Kind of a scary way of driving, but We see dual alternative loops all the time, like in our flowcharts. Not loops, excuse me. But I'm going to go to the idea of the single alternative. That's something or nothing. We're going to do something or we're not going to do anything. Like this. Why can I not find a diamond when I'm looking? Okay, it's the very second one. All right. So we have some line going to this, and then we have some kind of decision to make. Right. If x is less or equals 0, we're going to print out an error message. else we're not going to do a dang thing. Right? Like that. So this is a single alternative. If condition do something and then end if. Forget the fact that those lines are all lousy. I should clean it up later. Let's see if we can align our text appropriately. There we go. Like I said, I'll clean it up later. All right, so that's a single alternative if. I really think we're done with that. So a dual alternative I kind of see why they broke this up the way they did. They just listed the three conditions and then they went into the details. So I'm going to scroll back up to where I had 1, 2, and 3. Excuse me, 1 and 2. Insert our third choice, and then I'll go back and I'll say that this is selection structure. Right, I'm going to add a header to it. So this is a selection structure. But before that, I'm going to talk about structure 3, repeating code, looping. The loop structure, repeating actions while a condition remains true. And the condition is a Boolean condition. I could go back and add, insert the word Boolean in front of those two terms, condition right there. All right, now we're ready to talk about the selection structure, I believe. But just to make sure I don't make my notes spaghetti notes, first we're going to talk a little bit about sequence structures, but we've already talked about this. Sequence structure, one after the other, no indentions, no branching. The selection structure is the branch based on the Boolean condition, the Boolean expression. Now we're ready to talk. So I'm going to go back to my notes and explain what a dual alternative if is. Two alternatives. If something is true, do one process, else do the other process. So the dual alternative, I don't know why they listed first, because the single alternative would seem, single, double, whatever, following the notes. Take one of two actions like this. If condition, do thing one, else do thing two. End if. Then single alternative. Do something or nothing based on the condition. If condition, do thing one, end if. Yeah, makes sense. We just didn't call it single alternative and dual alternative in the past. So there's our single alternative. I'm just going to copy and paste this. Make it easy. The dual alternative is a little bit different. It just happens to go the other way on the no branch. and then hook back up at the end if. Right. So that's our dual alternative. So if condition, do something, else do something different. So if the employee belongs to the dental plan, subtract $40 from their pay. If that's the case, no else is required. I used to use an editor for an operating system called OS2 that if you typed if, it would immediately go in and add all this stuff. I'm just going to erase it. And then immediately you could type in, print A, whatever. And if you decided it was not dual alternative, you could leave all that or you could delete it yourself. And I guess it was, in a way, nice that it filled all that in, but it annoyed me. Because, you have to go back in and delete stuff. It's like it's trying to be too smart. Other programs try to be a little bit more generous, where as soon as you type that parentheses, it goes ahead and adds that one. Right, and that's kind of nice. And as soon as you add that thing, it tries to add, Python doesn't do all that. Idle doesn't do all that. So the supposed null case is a situation where nothing is done. Like that. Is x equal to 0? Yeah, do something. So what's the null case? The null case is if x is not equal to 0. In which case we don't do anything. Null meaning empty. Void doesn't do anything. Excuse me. So the loop structure repeats a set of actions while the condition remains true. So you have a loop header and you have a loop body. Don't know why they left off the term loop header. The loop header is the condition. The loop body is the code that you indent. So while x is less than 10, do something. That's called repetition or iteration. In the most common form of loop, the condition is checked first, and that's the only kind of loop that we have in our language. So, loop structure. That's structure 3. Statements are repeated while a condition, a Boolean condition, is true. Called repetition. Wait, they had two terms for that. Let me go make sure. Yeah, repetition or iteration. Guess I'll put quotes around it. So, one pass through the loop body is sometimes called an iteration. Want to get all computer sciencey about it. One pass through the loop body is often called an iteration of the loop. What is the body? It's the stuff that's indented. So you have a loop header, which is the condition. And then you have the loop body. And the loop body could be one statement. It could be a million statements, right? Loop body, loop body, loop body, right? Like that. We've seen loops already, I would expect. Like our while loops or our for loops when we were drawing multiple triangles. So that looks a lot like this. Yes, except the loop goes back to the condition again. And the book doesn't even show putting the word if or while in these blocks. I like doing so. While x is equal to 0, do something, and then the branching goes back up to that decision block when it's done. So keep repeating this while x is equal to 0. And then you, instead of calling that an end if, that would be an end while. Matter of fact, we don't even usually put the circle on that kind of thing. It's just the next thing we do after it. And if it was easy to draw an arrow coming from here to here, well, maybe it is. Right. That's just where we're coming in from the top. And I could have been adding that to all of them. Looks like I forgot to paste after I copied. No. Alrighty, okay. Well, good thing that dadgummit. Did not mean to do that. Okay. And so this is our while loop, our selection. No, that's not selection. The if statement is selection. So while condition, do something, end while. And of course, in our language, there is no end if, there is no end while. You can add them as comments like I sometimes do. They draw them a little bit differently. I draw the line coming down from the bottom and back. It doesn't matter. I usually stick the word while in the diamond to make it instantly obvious that it's not an if. Otherwise, the only way you can tell is which way the bottom branch goes, right? If it goes back up to the top or whether it goes back down into a circle. So while the test condition continues to be true, do something. While you continue to be hungry, take another bite of food. And then somehow determine if we're still hungry. So all logic problems can be solved using only sequence, where'd that go? Selection or loop. Using those three things in combination. Every program we write is going to do that. Structures can be combined in an infinite number of ways. Right? So you can start your program, with some sequence, and then you can have an if statement, and an if statement might branch two ways. And then one branch might go to a loop. The other branch might go off to some more sequence. Then they hook back up together at a certain point. We have some more sequence. And then down here there's a loop. Right, we're just stacking them. We're stacking them in different combinations. Right. So stacking structures end to end, and then the end statement. End if or end while just indicates the end of that structure. How does our language indicate the end of the structure? Back tabbing, right? If, do something, and a back tab. The first statement that's unindented after it's the end, of the structure. Here's an example of stacking our structures. Sequence, condition or selection, and then another condition down here, which is a loop, right? So that's pure stacking, but you can also nest structures. Nesting structures is when you stick one in the indented part of another, right? If you do something, then while, and then you do something else. And then you have an end while, and you have an end if, right? It's nested, it's inside. Just like inside the nest is an egg, or you have Russian nesting dolls with a nitty bitty and a bigger and a bigger and bigger, and so on. This does not show any nested structures. If there was a loop over here, then yeah, the loop would be nested inside the selection. And then you can nest anything inside of anything. You can nest an if inside of a selection. You can nest another selection inside of a loop, nest multiple loops together. Since we haven't written anything yet about actual code, it'd be kind of fun to throw some code in. So for those who aren't actually typing in the notes, you have something to type in, right? We're going to write something that prints out a table, a multiplication table, right? Like 1 times 2 is 2, 1 times 2 is 4, right? So we're going to use a nested loop in order to do that. So for row in range, 1 comma, it doesn't have to be nuts, a huge one, 6. For row in range, parentheses, 1 comma 6, in parentheses, colon. Now we're immediately going to put another structure, another loop. For call in column range, in range, 1 comma 6. For call in range, parentheses, 1 comma 6, in parentheses, colon. Print row times call, comma, followed by a tab. So quote, \t, end quote, in parentheses. That's just to make the data line up nice. Don't have to add the spaces that I just did. And then an end for, and then another end for. A for statement is just a fancy while loop. So everywhere where we wrote the word while, we could replace for, and it would still be valid statements. I guess that's even worth adding as a comment. Our language has 2 kinds of loops, while loops and for loops. All right, so if we run this, it should print out our little multiplication table. Looks like we're on L, lecture L.py. And I goofed. I forgot that I was going to have to add on one more special fancy thing in order to get this to work. And I was not going to introduce this at this time, but we're going to have to modify the print statement. What is happening? The print statement goes to the next line. Always, every time, right? Every time we print it goes to the next line. Not all languages do that. Some languages, if you execute a print statement, doesn't go to the next line unless you add a \n, a new line at the end of it. Well, you can configure, you can rejigger the print statement to not go to the next line by adding what's known as an end parameter. So after that \t, before the closing parentheses, right here, I'm changing the print line. Don't add those. You do end equals quote, quote. All that says is don't go to the next line. If I went back and I put a \n inside those quotes, which means new line, it would act just the way it did before. What we're telling it to do is don't go to the next line. This still is not a correct program, but it's one step closer. We're going to wind up making one more change. And the problem is, well, I'll run it and show you the problem. Oh. It almost looks like it's working, but really the text is just wrapping around, right? 1, 2, 3, 4, 5, 6, and if you run it, you know, your window's wider and it looks differently, right? And then 2, 4, 6, 8, 10, 3, 6, 9, right? Doesn't look right. And the problem is, it's just like if you were typing on a typewriter. We never went to the next line. We never added a print nothing, to go to the next line. All right, so don't add these comments. I'm going to erase them.
Question.
Yes, sir.
Why is the range stopping at 5?
We always write, good question, have we used for loops before? If not, that's fine. What the range statement does is this is one past the end. Just because. I didn't pick it, but what it means is this. This means while x is less than 6, not x is
You got it.
right, got it, right. So this is kind of a less than 6. Keep repeating while the range is less than 6. So it goes 1, 2, 3, 4, 5. I better add a comment to that effect. Right here, I'm going to do count from 1 to 5. Okay. I'm just adding some comments because, like I told you, to fix this, and I'm going to delete these, certainly don't need to type them, I need to add a print statement to go to the next line, right? Otherwise, it's just going to print 1, 2, 3, 4, 5, 6, 7, 8, right? And 2, 4. It's going to go on forever until the text wraps around on the screen. I need to add a blank print statement somewhere, just like hitting the enter key. Where should I stick that blank print statement? Should I stick it at place A, place B, place C, place D? Essentially, I want to keep typing until I hit the end of the row. Where am I going to put it?
I was trying to copy the notes, I'm sorry. What was the question?
No problem.
You said it was
You saw what it was doing before I'm going to make this change, which is just it kept printing and kept printing and kept printing without ever hitting enter, like on a typewriter.
Okay.
I need to add a print statement to go to the next line. To stop it from doing that, am I going to put it in place A, or place B, or place C, or place D? If I stick it at A, if that's what you said, it's just going to put a blank line above all this stuff. Good guess. I guess we could just keep going down the line. Somebody else. Thank you. Thank you very much. What would happen if I put it at B? Find out. So if I come over here and put a print statement here, and this, I'm going to wind up deleting this in a minute. We're back to that. It's not what I wanted. Why? Because it's printing the character turn, it's printing the new line, it's printing the return key after every number. All right, now we only have 2 choices left, C or D.
C.
Yeah, C. Why? Because this is printing out all the numbers in the row, or every column. But when we reach our end of our columns, we want to go back to the beginning. So that's where I'm going to stick my print statement. Go to next line on screen. And I'm going to delete these A's and B's like that. Now this should be right. Yep, and there's our little multiplication table. 2 times 3 is 6, 5 times 5 is 25. That's called a nested loop. Let's add a comment. Nested loop. To print out a grid of numbers, a multiplication table. So we have a loop inside a loop, meaning we have one loop that's indented inside the other. Anybody need typo correction? It's not printing out a cute little grid. So any individual task or step in a structure can be replaced by another structure. What does that mean? Do thing 1, do thing 2, do thing 3. Not have to necessarily type this because I'm going to start typing and slashing it. Thing 2 could be replaced with a loop or an if structure, right? If it turns out that that logic is more complicated, and then maybe that statement needs to be replaced with a structure. It needs to be more complicated. That might be a while loop. For while something, do right. And so on. Every task can be expanded with another structure to perform a more complicated function. Otherwise it's just get input, perform calculation, display output, right? Very broadly. But getting input may be a loop in order to get all the input. Perform the calculation may be a series of complex steps in order to get our answer. Meh. So nesting structures is placing one within the other, so you indent the nested structure, and each time you have another structure, you keep indenting until you've hit the end of the nested structures. And then you unindent. And so a block is a group of statements that executes as a single unit. This is a block of code. This is the block that's attached to this for statement, right? But all of this stuff is the block underneath the for loop. One pass through there, getting from there to there, is called one iteration of that loop. Now this loop repeats many times in here, so that's the iteration for that loop, right? This repeated 5 times as well, as it was printing out 5 columns. So how many times did we actually print something? What was our total number of numbers printed on the screen?
36.
If it was going to 6, but what did it really go to?
5 sometimes.
It went to 5, right, so it's 5 times 5. Very good. If I asked a question, like this, how many times is this going to repeat? And you didn't actually need to type it in, you'd have to figure out how many this was going to count and multiply it by how many this is going to count rather than add them together. So it would, just like you said, if we had made that a 7, then it would count out to 6. We'd have a multiplication table that went from 1 to 6, or we'd have a crash. I know what I did wrong, and I forgot to put my closing quotes from my opening quotes. Now to run again. Right, it went out to 6 now. I'm going to change that back to 6. If we haven't talked about the range statement much, it's all right for you to not realize that, but this always has to be one past where you're going. It keeps looping until this is not true, not after this is not true. Combining structures, we have a condition, we have a sequence of sequential statements that are nested inside that structure. Then we decided that in order to accomplish this, we needed a loop inside that selection structure, that if. Now it's getting really complicated. Not that complicated. How many indentation levels are we going to have? If, tab, tab. I mean, if, tab, statement, statement, statement. While, tab, if, tab. So we have 1 tab, 2 tabs, 3 tabs. Our code is nested 3 levels deep. If we look at the code up here, we'd see that to be the case. If, tab, while, tab, if, tab. So that's 1, 2, 3. I try to structure my flow charts so that every tab on here is indicated by going to the left. Excuse me, to the right. Unfortunately, else statements don't work that way because they have to have some other way to go, right? But kind of, in general, that's how I try to structure it. So a structured program has the following characteristics. It includes only combinations of those 3 basic structures. Every structure has a single entry point and a single exit point. Now for while loops, it's kind of harder to spot in a way, but let's go take a look. Right? This if statement only has one way that it can finally escape at the very end. Regardless. So is this a single alternative if, or is it a dual alternative if?
I can't see the time.
Doesn't matter what the if statement is, you just know it's branching one way and it's doing something, and if it branches the other way, it does nothing, so that makes it single alternative, right? This is an if statement that's a dual alternative because condition, do something, else, do something else. Here it's easier to spot, right? There's only one exit from this structure. The while loop is really hard to see because of the way they drew it. Let's see if I have one of these ready to look at. Is there not just an open? Oh, I just closed the tab and get back to the last one. Okay, fine. Well, that's as close as I'm going to get without a lot of looking. But if I pulled that over there, pulled that over there, we can tell it's a while because something comes all the way back here. So this entire while is one structure that contains other structures, and there's only one way out. Eventually, it loops back up to the top. Just like an if statement only has one way out. They have to join back up together. 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 And then when you reach the bottom of the while loop, so as a sequential only has one way out, right? Just at the bottom. An if only has one way out when they come back together at the end if. And a loop only has one way out after it rejoins, after it goes back to the condition. Then the no case is the way out, is the way out. So they're all a combination of the 3 basic structures. And any combination necessary. Every structure has a single entry and a single exit. Structures can be stacked or connected to one another only at their entries and their exits, and any structure can be nested within another structure. And remember at the beginning when I was saying something to the effect that I considered function calls a fourth structure? Let me see if I can show you why. programmatically, I mean, strictly speaking, these are all following the laws of the structures. However, logically, when you call that, it goes over here, it runs all that, and it comes back. And another call to it could do the same thing. Come over here, jump over, and come back. So to me, this kind of is not the idea of the three combinations of structures, because we have these subroutines, these subprocesses, these modules, these functions that get invoked, which causes a jump, so to speak, over there, and then a return. So I consider modules a fourth structure. They don't, so I'm not going to write it down. If I ask you to list the three structures and you say if, while, and module, I'd probably call it correct, even though the book calls it, sequential, just because I said that, right? Not that that's what I want you to say the answer. I just try not to be a jerk. If I mention something and you happen to remember it, I'm not going to count you off for it. You can see why I said we're going to get through this pretty quick. We're on slide 23 of 35. We've gone way more than half of it already. About time to stop, isn't it? Definitely time to stop. I don't have any homework ready for y'all from this. Is that a crime? Let me go look at how many assignments we've had. If we need another one, see if I can go grab one. Interest calculator. I don't think I have another one ready to slap on you from this semester. I'm comfortable with not giving it another one. All right. So that's the end of the lecture. Any questions? We may have a few minutes in which we can hang out and talk about homework, but it seems like they've tacked on a class that follows us. Definitely they've tacked on a class that follows us, so we can't hang out like we used to. But I work just downstairs, so we can go to my office. Any short 3-minute questions?
So we don't turn this in on D2?
Yeah, we're going to turn this in. I'm just not going to give you homework over it. Let me make a Dropbox for it. We're on L. And if you didn't type any of the notes, I hope you at least typed in our little multiplication table. If that wasn't the case, upload something saying you are here.